Right, everyone, welcome to this week's presentation of DBA Fundamentals. This week is Azure and SQL Server Disaster Recovery for Everyone, because everyone needs to know more about disaster recovery with Marco Obinu. Today is September 24th, so y'all get ready to sit back and get ready to learn about disaster recovery. In the top right-hand corner of the screen, you'll see the three leaders of the DBA Fundamentals group, Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. If you ever need to get hold of us for any reason, the easiest way is to reach out to us on X and ask us any questions you may have. Under that, you'll see our social media platforms. First one, and probably one of the more important ones, is Meetup, where probably most of you found today the actual link to today's presentation. On there, you'll find any of our coming up presentations. Under that is our website, dbafund.com. where you can find any of our past presentations as well as our future presentations as they come up. We have probably about the last 10 years worth of stuff in there. For those of you who don't know, we were actually part of the PASS before the complete disaster it ended up being. So yeah, we have lots of presentations from the past that you can find out all kinds of goodness for, and we have many more presentations coming up. So with that, also be sure to check us out.
一会儿妈带你走了，你还没吃呢。
Be sure to check us out and like us on dbafuntube.com, because that is our little YouTube site where we have all of our past presentations, and anything that comes up, we will be sure to put on there. So be sure to like and subscribe to our channel to make sure that you'll know exactly when the presentation does come up. Under that is our handle on X, DBA Fun, as well as our Slack and our LinkedIn groups. Be sure to link us on all of those. Some of our upcoming conferences that you should be aware of if you are not already. The big one is on the right-hand side of the screen. Tomorrow, if you're actually watching us live, is actually Future Data Driven 2024. This one is going to be huge because there's all kinds of things on Fabric. Anything with data, really, there's all kinds of goodness on there. Big one I remember being Fabric, though, because that's what I'm paying attention to a lot these days. Also, if you're available and can get to the United States anyway, PASS 2024 is coming up rather soon in November, early November. Be sure to come out to Seattle to actually join us at that. That should be great fun. If you're walking around and see me, be sure to stop me and say hello. Be sure to say how much you love DBA Fundamentals and all we do for you, or not, or anything you'd like to say. It's all good. I will be there in person. Reach out, hit me up. It's all good. Please remember to turn off your video and mute yourself. I'll be doing so in just a minute so we can focus on Marco. And please be sure to type into the chat anything you have for questions. I'll be throwing them over to him later on in the presentation. So with that, over to Marco.
All right. Good evening, good morning, or good afternoon, wherever you are. I'm Marco Obinu. I'm based in Italy. And this evening, I plan to talk about how you can implement a simple disaster recovery for your environment on premises that goes to Azure. So let me share my screen and set the window in the right position, and so you should be able to see my presentation. So a couple of words about me. I'm currently working at Microsoft as a technical trainer, but this session is completely held in with a community in mind, and it's based upon my previous experience as a consultant when I was working a lot with SQL Server. And be aware that opinions are my own. I want to express what I like and what I don't like about the different solutions we have in a complete free way. Now, let's move on. What's in it for us? What we will be discussing in this session? Well, we will have some basic concepts around how a disaster recovery plan should be made, and what are the advantages of implementing a disaster recovery site on Azure for a SQL Server implementation. Then we will go through the different BCDR, business continuity and disaster recovery technologies that we can leverage in a hybrid scenario. So when we have something on premises and something on the cloud side. Let's move on. Back to the basics. Let's introduce some terminology, some terms. What happens when we have a database and a disaster strikes? Well, a couple of things will happen. We need a certain amount of time to bring the service online again, and then for sure we will have a certain amount of data loss that depends on how frequently we take care of our workload, we protect our workload. We, as the technical folks here, we need to define a technical solution which is able to cope with the RTO and RPO requirements that the business give us. RTO stands for recovery time objectives, and it's the time we can spend in recovering a service after a disaster happened. RPO, on the other side, stands for recovery point objectives, and it means how much data we can lose after a failure. We need to find the right technical solution for us to remain inside those requirements. And we need also to be aware that when we try to reduce the impact of RTO and RPO, we usually face an increased costs and complexity for our architectures. So in order to keep those aspects as low as feasible, we need to challenge the business. So we need to go to the business and ask them some things. We need to conduct a risk impact analysis and a business impact analysis. We need to be sure about what happens if for some reasons our database goes offline. What is the economic impact? What is the reputational impact of this downtime? And do we have to take care about compliancy? Do we have some auditors that can ask why our system was offline at a certain time? If so, we need to take care of it. And we need to challenge the business, because if I go to the business and say, for how long you can survive if the system goes down, they usually say something like, oh no, the system can't go offline. We need something that stays available for 24/7. And that means costs for us, costs and complexity. We should come out from these kind of meetings with the information about the real RTO and RPO prerequisites we need to honor. And then we should conduct a feasibility study. We should test what we can achieve, if we can stay below those requirements with a certain technology, or if we switch to another one, and then how much the new technology will cost. And of course, when doing that, we need to take care of the overall picture. It's not only a SQL Server aspect, this one, but we should also consider the entire architecture protection. It doesn't matter if we send rockets to the moon on the SQL Server side, but then we need hours to restore the application on the application side. So we need to find a good balance, and then we need to design a business continuity plan which contains all the steps, all the technologies, all the configuration we need to have in place in order to be able to fail over from one side to the other, and then eventually fail back. And also we need to maintain this plan over the time. We need to test it frequently. We need to update it if something changes on both sides. So this is a not ever ongoing project, let me say. Having said that, what are the advantages of using Azure as a DR site? Well, if we implement a DR solution on an on-premises data center, we usually has complexity, costs, and effort that comes from these implementations. And usually they are often way higher than the benefits we can have from a DR side. A DR is something like an insurance. It's something you want to pay, but you don't really want to leverage it, because if you are leveraging it, something bad happened. So what happens if we had Azure and the new technologies it offers us in the equation? Then we obtain a better balance. What about costs? Well, it depends. We have costs that depends on the kind of technology we want to implement. As we will be seeing, some of them are really cheap, some of them requires more in terms of money. At least on the licensing cost side, we had an evolution starting with SQL 2019 licensing model. Up until that version, in a cross-premises scenario, so when you have something on-prem and then you have something passive in the cloud, you have to cover the overall number of cores managed by that architecture. Starting with SQL 2019, if you have the software assurance on the license, then you are free to leverage a passive secondary disaster recovery site on premises or on cloud without any additional costs in terms of licenses. So at least on this area, it's better than before. Then, when we deal with hybrid technologies, usually we work in an infrastructure as a service model. So our target for the recovery on the Azure side will be based on Azure SQL VM. On Azure SQL VM, you are in a pure infrastructure as a service model, so you are responsible for everything that runs on top of the VM. So you are responsible for the operating system, for the runtime, and then you need to take care about the data and the application that runs on the VM. Now, let's switch to the different technologies we can leverage. I tried to summarize all of them, and I had my own perspective about what I like and what I don't like about them. Let's start with, for example, backup to URL. Super simple. In this scenario, we have an on-premises database, which is accessed by users directly from their laptop. And then at regular interval, you are executing the backup to URL statement in order to create backup copies of your database over an Azure storage account. This is super simple, super cheap, since the storage, the blob storage on the Azure storage account is one of the cheapest one we have in Azure. Which are the requirements for implementing this? Well, it's supported starting from SQL 2012. So if you are not dealing with the super legacy versions, you are okay with that. And you can back up database in every recovery model we have. So you don't have any specific requirement for your recovery model. In terms of complexity, well, super simple to implement, but then when it comes to recover those databases, the complexity happens. What about RPO and RTO? Well, the RPO depends on how frequently you do the backup, how big those backup files are, and how fast your connectivity to Azure is. When it comes to RTO, here, what happens in case of a disaster? Well, then we have backup files in Azure. It's like an offsite backup, but we don't have anything running in Azure. So the first thing first is to deploy an Azure SQL VM and to restore the databases on it. then we can point our users to the new instance, and that requires time. So not so happy in terms of RTO, recovery time objectives. What is the data access we have on the DR side, on the Azure side? Well, since we have backups there, we can restore on the fly on another instance just to recover some data. So not ideal, but it can work. Let's move on. Let's add some complexity. Let's add some speed to the system. We can leverage the well-known log shipping mechanisms that's in SQL Server since ages. Here, what you have, you need an on-premises instance, then you need a instance in Azure, so we need a running VM on the other side, and here costs are increased because you need to maintain an entire virtual machine when before you were only running a storage account on the other side, so it was way more cheaper than this. And then you leverage the well-known log shipping mechanism that will bring your T-log backups from one side to the other through a VPN connectivity. So you need a cross-premises connectivity, and you can backup your databases on-prem and restore them on the other side with the no recovery option. Key aspects of this implementation. Well, it's supported by every SQL Server version I can recall, if the version has the SQL Server agent, because the whole mechanism relies on the scheduling capabilities of the agent. The recovery models here needs to be full because we need to leverage T-log backups. And the complexity of the implementation is quite high because we have plenty of jobs, SQL agent jobs that are related to every database we have if we leverage the standard implementation. What about RPO? Well, the RPO, again, depends on the workload. It depends on the backup sizes. It depends on how fast the network is. What happens in case of a disaster? We lose the on-premises site. We need to restore with the recovery the remote databases, and then we can say our clients, okay, now switch to the new instance. We can achieve that result in several different ways, depending on the kind of connectivity they have, but it works. Can be better, but at least it's better than before. What about the data access on the DR side? We have a running instance on the remote side, but our databases are restored with no recovery, so they are offline. To bring them online, we need to restore them with standby. So we need a standby file, and so we can keep for a certain amount of time the database online. We can consult it, and then we can discard the standby file. This without impacting the log shipping mechanism. And if for some reason this mechanism is not suitable for us because we don't like it, we can then think to customize it. We have plenty of options here. For example, we can implement a scheduled task with PowerShell, maybe the wonderful DBA tools module, to execute a backup to a URL over a storage account. And then on the Azure side, we can leverage, for example, an automation account to schedule the restore from URL commandlets, again from DBA tools. And we can achieve a similar result by implementing everything by ourselves, maybe in a way we are more comfortable to work with. Let's move on. And let's see the third technology we have here. So database mirroring. I know it's deprecated since a lot of time, but it's still there. So you might think about using it if you don't have any other option available. In this case, we have again, an on-premises instance, we need an Azure SQL VM on the other side, and then through replication that can be synchronous or asynchronous, we send the transaction logs informations from the principal database to the mirror one. So the mirror one is constantly kept in alignment with the principal one. And how much time is behind the principal one depends on the synchronous or asynchronous methods we use for replicating it. Since we are dealing, usually in this kind of scenario, we are dealing with a geographical connectivity from our on-premises data center to the cloud one, we have to leverage the asynchronous replication. Otherwise, a whole lot of latency will be added to our application. And for doing that, we need SQL Server Enterprise Edition, and this had costs. Then here, you are seeing an implementation based upon the exchange of certificates between the nodes that are composing this environment. But usually, in my experience, I always had to deal with Active Directory deployments. So let me add them to the overall schema. So let's add a couple of domain controllers. Let's add a cross-premises private connectivity over the VPN, and we can have our asynchronous replication flow that goes from the principal to the mirror database. What I like and what I don't like about this. First of all, we need the Enterprise Edition, we said, because we need the asynchronous replication. The recovery model must be full because we need to send transaction log information over the line. The complexity of this implementation is moderate because you have to establish a mirroring session for each database you have. You can't group them. So if you have two databases, you need to create two mirroring sessions. What about RPO and RTO here? Well, RPO is nice because even with asynchronous replication, if you have a good connectivity and you have a moderate workload, then your remote mirror copies can be quite near the status of the principal ones. RTO, on the other side, are nice here because we can say to our clients that they need to leverage a failover partner in their connectivity string, in their connection string, so they are already aware there's someone who can take care of their queries if for some reason the principal database are taken offline. And when a disaster strikes and you lose the connectivity, then you simply have to bring your remote databases online. This is a manual action and may produce a data loss since those databases are not synchronized with the on-premises data center. They are subject to an asynchronous copy. But then once they are online, the clients can connect to them through the failover partner property in their connection string. So here you are quite fast in restarting your services. What about the data which resides on the Azure side? Can you access it? Well, you can do that by taking database snapshots. You can issue database snapshots over the mirror databases, and then you can bring them online as a static copy, and you can consult them. Let's move on, and let's go with one of my favorite technologies here, the availability groups one. Here, the scenario is a bit more complex. We will spend some time more here. With availability groups, you have typically, on the on-premises side, at least a couple of nodes configured in synchronous replication. That means that you have two servers with independent storage. One hold the online databases, which are accessed by the user through an availability group listener, which is like a VIP between the different nodes. And then those primary databases are taken in synchronous with secondary copies which reside on another instance, on another independent instance. The synchronous replication allows you for automatic failover and so for high availability on the on-premises side. Then you can implement a third node on the Azure side. You can extend the underlying failover cluster to the third node and add an additional replica for your database, this time in a synchronous mode, because again, this works like mirroring in terms of performance. If you are dealing with a geographical connectivity, a cross-premises connectivity, you really want to have asynchronous replication on the DR side. Now, in the different implementation of availability groups we had in the different version of SQL servers released over the years, you can have also some different configurations. We will take care about them in a while. What I like about this technology and what I don't like. Well, first of all, we need the enterprise edition for implementing that, at least if we want to deal with availability groups that can handle more than one database inside it. So if we want to overcome one of the limits we had with database mirroring, then we can leverage, starting from SQL 2016, we can leverage basic availability group, and we will be talking about that in a while. The recovery model here needs to be full again, because we still need to send the flow of transaction logs. The complexity can be better, but it can be also worse. So it's moderate, in my opinion. RPO and RTO for this solution. It depends. I love the RPO because this mechanism is really fast. In average scenarios, your Azure copies are quite near to the on-premises ones, even if they are asynchronously replicated. And the RTO here is super fast. It's super fast because the database goes back online in a really fast manner. And what about the data access on the DR side? Well, with availability groups, depending on the license we have, we can leverage the readable secondaries. So we can leverage the database we have on the DR side to and so we are able to use them for example, for reporting purposes. This is super cool. Now let's have a look of what's under the hood for availability, always-on availability groups, and how we can implement them on an hybrid environment. This is what you usually see if you have a 3 nodes always-on availability group cluster on premises. You have 3 independent nodes in terms of storage, so no shared storage here. This is not a SQL Server failover cluster instance. And then on top of those, on that independent storage, you have 3 copies of your databases. One of them is the primary replica, which is the one which is accessible in a read-write from your in a read-write mode from your users through a availability group listener, which is provided with a virtual network name and IP address resources at the cluster level. Then we also have the cluster groups that maintain the cluster online, the Windows Server failover cluster online. all of the nodes are provided with their own quorum vote. And the number of quorum vote needs to be odd. What happens with the vote? So if you have an odd number of nodes, or at least an odd number of votes, because you can add witnesses to correct the scenario, if you lose one of the node, nothing happens. The workload is still online. If you lose two of the nodes, then also your cluster goes down. But then you can also force it to start by fixing the quorum. So you can forcibly bring him online. Why this is important? Well, this is important because when we deal with a geographical cluster, like in this scenario, and when this geographical cluster is placed on Azure, we need to add a couple of things to our configuration. Here, what you can see, we have an on-prem network, so an on-prem site that hosts two nodes for our cluster. Then we have a third node, which is placed on Azure, so inside an Azure virtual network. All of the nodes are part of the same cluster. As you can see, this cluster spans all over the three nodes, and all of them are based on independent storage. Now, we have three replicas as before, one primary replica, two secondary replicas in this scenario. What happens here? We have to remove the quorum vote from the remote node because we don't want that if there's a connectivity issue between the two parts of the cluster, then the on-premises, let me say, main part of the cluster can be affected by that connectivity issue. So we need to remove the vote from there. And so we need then to add a witness on-prem in order to restore the odd number of quorum votes. Then we also have to deal with this one, a load balancer. Why we need that? Well, you know, when you implement a failover cluster on-prem, you are leveraging cluster IP resources, both for the cluster and for the SQL Server components like the always-on availability group listener, for example. And those cluster IP resources are maintained by loopback network interfaces, which are managed by the cluster. When you switch to Azure, you can't leverage those loopback adapters because if you assign a private IP inside your guest operating system without letting Azure know about the usage of that IP address, then that IP address you assign to the cluster IP resource can be reused by someone else. And this can lead to issues with connectivity issues. To avoid this, you need to handle a floating IP between the different nodes that compose your clusters, and you need to leverage a load balancer for doing that. There's a particular configuration you need to apply to an Azure load balancer in order to obtain a floating IP. Are there any other options here? Yes, they are. They were added later. I've never had the chance to work in a production environment with them because I stopped working with SQL Server a while ago. But for example, you can leverage distributed network names, or you can create a multi-subnet cluster on Azure in order to avoid the Azure load balancer. Why I'm talking about that? Because one of these technology can be leveraged then. Let me spend a couple of words on this topic later in a couple of slides. Now, let's look at the failover mechanism. We have a simplified version of the previous schema where we have a couple of nodes, node 1 and node 2 on the on-premises side and node 3 on the cluster side. The secondary replica on node 2 is in a synchronous replication way, while the secondary replica in the node 3, since it's placed on Azure, it's configured for asynchronous replication. And we have two couple of workloads here. We have users which are trying to access the database through the AG listener network name, which is the name of this resource that is connected to the availability group. And then they connect with the multi-subnet failover property set to true in their connection string. Then we have the reporting workload that is connecting to the database in a read-only fashion. And so the reporting workload leveraged these properties in the connection string. Data source is still pointing to the listener. Multi-subnet failover true, absolutely yes. And then finally, we need to specify the application intent to read-only. In that way, what happens? The users are connecting through the listener to the primary replica, while the reports are connecting through the listener, and then they are redirected to one of the secondary replicas via the application intent. What happened then if we fail over from one node to another one on-prem? We can leverage in this kind of scenario, we are failing over another node on-prem. The other node was in synchronous replication, so we can leverage automatic failover provided by the availability group. What happened to the users and to the different workloads? Well, the users are still pointing to the availability group listener, so in a while they will be able to connect that to the new primary replica that is provided you via the availability group listener, the AG listener. Reports do the same, reach the listener, and then via the listener, they are redirected to the secondary replica. What happens in case of a disaster? Well, if a disaster strike, then we completely lose the on-premises data center. So the cluster here goes down because we don't have quorum votes anymore, because this has a 0 in terms of quorum, and all the votes were in the on-premises network, and they are not available anymore since we are under a disaster. What we have to do? First of all, we need to forcibly start the cluster and bring it online on a single node. Then, after a while, since our users are leveraging this multi-subnet failover property in their connection string, they should be able to reach the new IP assigned to the listener, the new IP which resides on the Azure network. This is the basics of the failover mechanism. Then I said that over the time, new versions of SQL servers introduced additional features to always-on availability groups. One of the features that were added in SQL 2016 was the always-on distributed availability group. This is nice because in this scenario, you can have two independent clusters configured for always-on availability groups, and then you can have an always-on availability groups that keep those availability groups synchronized between them. So you have an availability group of availability groups. This is useful because you don't have to create a stretched cluster between different networks. And especially when it comes to Azure, it can be helpful because with this configuration, you can potentially avoid this virtual network name and IP part that requires you to work with a load balancer, and you can potentially switch to a multi-subnet always-on availability group, a multi-subnet cluster that hosts an availability group. In this case, you don't have to deal, this one is not present anymore. The cluster, the failover cluster, the underlying failover cluster leverage distributed network names. And on the SQL side, you can leverage the multi-subnet failover approach, because distributed network name have some limitations and they can't work with distributed availability groups. So the other options here is the multi-subnet cluster. That's a way for us to reduce the complexity of maintaining a structured cluster between environments. Cool, but it requires money, because here we are dealing with enterprise editions and we need a lot of nodes. So what happens if we are on the budget side? Well, we can eventually leverage the always-on basic availability group, which were introduced with SQL 2016 Standard Edition. Here you have a mix of the benefits of an availability group and the behavior, which is quite similar to a mirroring session. So you can create a basic availability group which contains only one database. You need to work database by database. You can't create groups of multiple databases, but then the mechanism is the same I shown you before, with the exception that you can have only one replica which can be synchronous or asynchronous, so you can't have multiple replicas. If you deal with multiple databases, then you need to create an availability group for each of them. So the architecture can be a bit more complex here. But the nice thing is that you can mix things together. You can have a failover cluster instance, a traditional SQL Server failover cluster on premises, and then you can mix that failover cluster instance. You can use the failover cluster instance as the primary replica in an always-on availability group that spans both the cluster on the on-premises side and an additional node on the Azure side. And this is what we will be seeing in a while for our demo session. Before going through that, let's cover the last possibilities we have, talking about Azure Site Recovery. What is Azure Site Recovery? Well, Azure Site Recovery is an Azure native service which orchestrates disaster recovery plans from an on-premises scenario to the cloud, or from a cloud environment to another cloud environment. So we can use Azure Site Recovery to do a Azure to Azure disaster recovery plan. This might be useful if our Azure infrastructure requires geographic protection against eventual region failures. So usually what we can do with Azure Site Recovery, in my experience, I always used it to replicate the front-end part of our implementation. So I usually used the SQL Server native technologies for handling the disaster recovery part of the database side. In this scenario, in the schema you can see here, we have a web server which is replicated by ASR. So on the cloud side, we usually have only a replica of the storage used by the web server. No running virtual machines are on the cloud side until a disaster strike. Then for the SQL Server part, here I'm leveraging an always-on availability group implementation with a geographic distribution of the node. If the disaster strike, I lose the entire on-premises environment, then I can leverage Azure Site Recovery to orchestrate the failover over the cloud. And in the recovery plan I can create in Site Recovery, I can create different tasks that, for example, restore the VM by creating a new VM starting from the existing one or from the existing disks we have in the recovery services vault. And then the same recovery plan can execute an automatic step in order to forcibly turn on the Azure SQL, the SQL Server part of the architecture. So we can forcibly start the cluster, we can bring the databases online, and then our application can connect again to the database. Eventually, in certain scenarios, we can even leverage Azure Site Recovery for replicating our database stack. It depends on how big, how tough is the database stack. If we are under the limitation introduced by ASR in terms of speed of replication, we can think about replicating also the database through Azure Site Recovery. In that scenario, we have only the storage, the replicated storage on the cloud side, so no running nodes with the SQL Server on the Azure side. And when the disaster happens, then we simply need to leverage Azure Site Recovery to generate new VMs starting from the archived disks, and then we can bring the service back. This works if we have a single node SQL Server on-prem. Then if we have a more complex solution, like for example, if we have a SQL Server failover cluster instance with the shared storage, to leverage ASR, we need to implement a mirror on-prem. So we need to implement a mirroring configuration in order to have a standalone instance which has a copy of the databases, and then we can apply Site Recovery replica on top of that mirror one. This is not really useful in my opinion. I would prefer to use a different approach for handling this kind of situation. We covered all the aspects we mentioned before. Do we miss something? Well, there's a new technology we can leverage, which is based on platform as a service. And I'm mentioning here the Azure SQL Managed Instance link. Azure SQL Managed Instance link is a feature that you can leverage if you need to migrate your on-premises databases to an Azure SQL Managed Instance, but it can also be used as a DR solution for SQL Server 2022 instances. So basically, you are replicating your database from your on-premises instance to an Azure SQL Managed Instance, so a PaaS service that don't need a lot of maintenance of administrative effort on our side. And then if we fail over to the cloud part, we can now fail back to the on-prem environment when needed via an offline procedure or via an online procedure, which is still in preview right now. So this can be useful if you are dealing with new versions of SQL Server and you want to avoid the complexity of configuring a whole infrastructure as a service architecture on cloud. Now we have a few minutes, so let me go through the demo. For doing that, I have a pre-recorded video. This is not really new, but it's still valid here. And what we are trying to achieve, we have a SQL Server 2017 standard SQL failover cluster instance on-prem. So we have a two-node failover cluster on-prem, and we want to extend that on cloud for disaster recovery. So what we will be leveraging basic availability groups for doing that. So we will need only SQL Server standard edition licenses. And I know this is quite an uncommon scenario, but I tried to mix all the worst things I could find. And then if it works in this way, then it will work for better scenarios with better licenses and eventually better features. Now, what we have on premises, we have a 2 nodes SQL Server failover cluster instance that has an iSCSI shared storage and a couple of DBs. So we need to create 2 basic availability groups because we have 2 databases here. And on the Azure side, we have a standalone instance, an Azure SQL VM with a SQL Server instance on top of it, with local storage only and no DB at the time. The first step is just to go through the configuration we have. We have this SQL cluster on premises, which is composed by a couple of nodes, SQL 01, SQL 02, and we have a shared disk. Then if we connect to the failover cluster on-prem, we can see we have a couple of databases and no always-on high availability configuration at the moment. Now we can start connecting to the remote side and preparing the environment. So we can reproduce the same checks via PowerShell, via the DBA tools commandlet. I'm connecting to the SQL on-prem database here, and as you can see, there's no high availability configuration in place. And we have a couple of databases on the on-premises environment. Now, if we switch to the Azure environment, we have the SQL DR node, which has no always-on availability group configuration in place, and it has no databases in it. Now we can switch to the step number 2. In step number 2, we need to provision an internal load balancer that will be responsible for providing us the floating IPs we need for the cluster. We need one IP for the Windows Server failover cluster that is underlying our always-on availability group solution. And then we need 2 different IPs for the basic availability groups. We have 2 databases. We are dealing with basic availability groups. We need 2 of them, and so we need 2 listeners and 2 IPs. So a total of 3 floating IPs. Let's create them. I did it via a script, and I'll share the script after the presentation. Everything is on a GitHub repo, so you can have a look at it in a more quiet way. Now we are ready for the step number 3, which is the inserting the SQL DR node into the cluster. So here we have to add the SQL DR node to the failover cluster, but we need then to exclude those third node as an owner for the SQL Server failover cluster instance because it's not part. It's a third node for the entire Windows Server failover cluster, but it's not yet suitable for the SQL Server side of the configuration. So let's add the node here. First of all, on SQL DR, we need to install the Windows feature for failover clustering, and then we can add the third node without any storage, so no shared storage here. As you can see, in the failover cluster manager configuration, a third node step in, and then we need to add the IP address of the load balancer in Azure to the possible IP addresses that the cluster resource can leverage. And then we need to define also the dependencies between the cluster network name and the new IP we added. Step number 4, we need to take care of the quorum votes. So we need to remove the quorum vote on the SQL DR side, and then we need to install the availability group prerequisites in order to proceed with the configuration. First of all, we need to remove the quorum vote from the cloud side. So through those commandlets, which are part of the failover cluster modules by Microsoft, we can take care of this configuration. Then we should remove the new cluster node we added, the SQL DR1, from the possible owners of the SQL Server failover cluster instance we have on-prem, because we can't failover the failover cluster instance to SQL DR node. It's not ready for doing that. Then, again, going through the DBA tools commandlets, we go and install the availability groups prerequisites on both on all the cluster nodes. And we need to restart the cluster just to be sure these changes are taken into account. We need that on the on-premises instance, and then we need to do that on the DR side. Here I'm configuring the credential for the service account used on the SQL DR side, and I will restart also the service in order to leverage the new credential that I've added here. And we are ready to go to the additional steps. So we need to create a shared storage that will allow us to host the backups of the database that will seed the replicas, the secondary replicas in cloud. And we need to create the mirroring endpoints used by the always-on availability groups mechanism. And now we are ready to move on with step number 5 that creates the availability groups. So here, by leveraging again a commandlet from DBA tools, we create a basic availability group for the database number 1, which is called AG1. And then we do the same for creating a second copy of the availability group for the second databases. And it's really useful to be able to do that via PowerShell with that awesome module. Finally, let's move on. We need to create the listeners. Here we need to add the cluster resources that supports the listeners. And as you can see here in the schema, the listeners we will be creating, they have a couple of IPs, each one. One IP is part of the on-premises network, and the IP 10.1.something is part of the Azure network. So there will be an IP online when the availability group listener is online on the on-premises environment, and another one that comes online when we have a failover to the DR side. Let's do it again by leveraging PowerShell. For first listener, as you can see here, I'm adding a couple of IPs in it. And then I'm configuring the cluster for implementing these changes. And now we are on the second listener, other IPs, and then other changes to the cluster groups. Finally, we need to update some properties on the cluster sides to be faster while reconnecting after a disaster. I lowered the time to live for example, on the DNS side and so on. And we are ready to go. Then we are supposed to replicate logins, jobs, and so on, and we can leverage DBA tools for doing that. But it's not the case in this demo environment. Now we can do a quick check of the post-deployment scenario. So we can switch to the failover cluster manager. We can see we have an availability group with a couple of IPs and another availability group with another couple of IPs from different networks. And we have an always-on availability group in place. We are seeing that when connected to the failover cluster instance on-prem. Everything is green, so everything is under replication. And if we connect to the database and we connect to the via the one of the availability group listeners we have, we can test the connectivity to this listener, and we can see this is provided by an IP address which is based on the on-prem network. And if we try to connect to a database through the listener, we can check everything is online. So we have the database. We can check the name of the cluster nodes we have in the system, and we can see SQL 01 and SQL 02, which are parts of the SQL Server failover cluster nodes, and one of them was holding the running instance. Now I'm forcing a failover on the on-premises failover cluster instance, and after a reconnection, you can see that everything is online again, and then there's the new owner for our instance. And if I check the server name, it's the name of the cluster. I'm connected through the listener, but the @ server name returns me the name of the failover cluster instance, SQL on-prem. Now, let's simulate a failure. So let's destroy the on-prem environment. I will be turning off the machines in my Hyper-V environment. So everything goes offline immediately, and I have lost everything on the on-premises side. On the DR side, instead, my instance is still up and running, but the availability group doesn't know what to do. It's in the resolving state. It's not able to work anymore. I'm not able to connect to the databases. They are in not synchronizing state, and if I try to connect them to them, that's not good. Still, if I point to the listener, if I try to resolve the address of the listener, it's still related to the on-premises IP address. So the system didn't do any kind of failover because there's no automatic failover in this scenario. You are in a DR scenario, you need to govern the failover. And the database itself, it's not available because it's not able to accept connections. So what we can do now, just to be sure that we are in a completely disaster, I also removed the on-premises witness I was using for the failover cluster. So now all the on-prem environment has gone. Let's bring the DR side online. That means that we need to stop the cluster service on the DR node if it's still running. And then we need to start the cluster via the fixed quorum switch. This brings, in a while, the remaining node online. So as you can see, I'm checking the status of the cluster nodes, and after a while, it goes offline. Then, by leveraging again DBA tools commandlet, we can switch the availability group. We can fail over the availability group, and we need to allow for data loss since the DR availability group were under asynchronous replication. So we need to force allow data loss. And that's it. In a while, everything comes back online, and we can reach our database. Of course, we are still without the on-premises data center, but then we can start working on restoring it. Our database is available for our users while we work on bringing the database online again on-prem. And as you can see, the listener is now available via the DR IP address. And if we connect to it, so if we connect to one of the listeners, we are able to connect now, and we can leverage the databases. We can reproduce the same checks we were doing before. And all the tables are there. And if we query the cluster nodes DMV from the cluster, now we can't find anything because SQL DR is a node which is not part of the SQL Server failover cluster instance we had on-prem. And the server name now is SQL DR. It's not SQL on-prem anymore because we are not on the failover cluster instance anymore. That's all on the demo side. I hope it was interesting enough for you. I will leave you with some resources. There's the demo scripts you can check for implementing everything. They worked. If you have any issue with them, just let me know. I can try to update them. Then you have a link to the official documentation. And just in case, if you want to see again the demo, I've also a video in my YouTube channel if you want to go and see it. That's all on my side. If you have any question, I'm more than happy to answer them. Otherwise, let's keep in touch. Here you can find my contacts, my social media references, and I would be more than happy to remain in touch with you.
Marco, this has been awesome. I know there are people who are gathering up the list of questions they have, so I'll give them a few minutes here.
Yeah.
Want to remind everyone that on October 22nd, we'll be having Torsten Straub create a YAML CI/CD pipeline for Azure SQL Database. That is our next presentation, so please come on back and join us if you have any questions on YAML CI/CD, because that one sounds actually kind of fun. If you've ever had to do anything in CI/CD pipelines, YAML is definitely one of the easy ways to go with it, so be sure to join us on that. And as always, Marco, great presentation. You covered everything and then some on disaster recovery, so.
I hope it was useful. It's something I really like. I try to cover everything. Then, of course, you need to go deeper in each of the topics if you plan to implement them. But I think it can be a good starting point, at least.
Amen. I mean, yeah, as you said, if the more you try to work with some of these tools, the more you have to go very in depth to get it just right, because otherwise there can be some fun things you find out.
Absolutely.
All right, so it doesn't look like anyone is typing into the chat. I know several people have left because they've been running a little long. All good. So with that, I want to thank everyone for coming. As Marco said, if you have any questions, please be sure to reach out to him. His contact information is on the screen. If you have any other questions, please be sure to contact me. I send it out in the link every time that we send an email out. And I'll be sure to include the link to the slide deck as well for this presentation. So with that, thank you all very much. Have a great day, and we will talk at y'all soon.
Thank you. Bye-bye all.